Hello, everybody. How you guys doing today? A little bit of a off guard. I didn't do any announcement or anything. I just sat down and I started recording and streaming here. So we're gonna get this thing just going right off the bat here. No lead at time, no nothing. So let's go ahead and let that Discord know what's going on. All right. 6:30 p.m. All right. Hey Tim, how's it going? How you doing? Welcome in. How's it going? I hope you're doing really well. How are you doing? All right, we're getting this stream kicked off. Just getting the announcement sent out. Um, I am live. Cool. All right, let's get this going. Welcome, Tim. It's awesome to hear from you. First one in. Congratulations. Hope you're doing really well. Okay, let's go ahead and get started here. R 5.4. Okay. All right, we're gonna get started here. How's everybody doing today? Welcome. Today is Sunday, December 22nd, 2024. The streaming streak, steady streak stays alive once again. Another day. We are moving on, keep learning, and one day after another. I hope you guys are learning with me here. It's so awesome to have you guys here. Okay, so 5.4 asks us to look at the dynamic class given in code fragment 5.3 and modify the get item method to support negative indices. So let's make sure we have this in there properly. All right, so let's go take a peek at the code fragment 5.3. Code fragment 5.2, 5.3. So the dunder get item method takes a dunder get item, right? And then this has some self value associated and then some k for an index value to get at the item. So if not 0, less than or equal to k, which is less than self dot underscore n, right? We're going to raise index error for quote invalid index close quote. We're going to return self dot array at index value k. So this is right now like what it says is the get item does not support negative indices via this statement here. So we need to say if k is greater than or equal to 0, but less than so we're not going to say if not. So if instead of this, right, we're not going to raise an index error. We're going to just return the value at this given point. You know, if k is between 0, the first item in the list, or the all the way up to the nth item in the list, right? Yo, Tanmay, thanks so much for coming in. It's so awesome to hear from you. How you doing? Welcome back. Welcome back. All right, and someone just gave us the balloons. We just got a subscriber, so thank you so much to whoever that was. I really appreciate you. Okay, so the if k is between 0 and the length of the total list, we can return the value index at k, right? Um, else, or elif k, so it's negative self dot underscore n, right? So elif negative between k and -1, less than or equal to -1, we're going to return self dot underscore a at, so how can we provide this? So n would be a negative length for the total amount. So let's say like -5. -1 to -5 would provide us the last value. So if we have a list here with 4, 2, 5, 1, 6, right? We have I is equal to -1, -2, -3, -4, -5. So you can be -5. Right? So if that's the case, if we need to return a value associated with this decreasing index, right? If we return, we don't want to return the negative first value. We return, because you can't really do, we have to report the opposite direction. So it would be n is 5, and we want the, let's say we want the negative second value. It would be 5 minus k minus n. So if we wanted index -1, -1, no, it'd be k plus n. So if they provided the negative first index, we would respond with the value of k -1 plus 5. So -1, 0, 1, 2, 3, 4, 5. It would be k plus n minus 1. So it'd be, if it's k plus n minus 1, if we provide and negative 1, we want the 6. So we add 5 to it, negative 1 plus 5 is index value 4, 0, 1, 2, 3, 4. No, just k plus n, right? Yeah. So we would provide index value. If we were given index value for a negative 1, we add n to it. So negative 1 plus n would be 5, so would be 0, 1, 2, 3, 4 for the 5 elements. 0, 1, 2, 3, 0, 1, 2, 3, and 4. Yeah, k plus n. All right, hey Script Serpent, I appreciate you coming in today. How you doing? Welcome back. It's good to hear from you. So if k can go all the way to negative 5, so is this right? Is this it here? So k can be negative 1 and it can be negative 5. So that's why we have these less than or equal to or greater than or equal to. So this will be negative 5 and negative 1. If we wanted the negative first index, we'd have to add n to. If we wanted the negative second index, we'd add n to it, which is 5. So negative second would be negative first, 0, 1, 0, 1, 2, 3, which give us that one. Exactly. I think this is it. Your approach to extending the get item method to support negative indexing is almost correct, but there's a small error in the computation for negative indexes. Specifically in the return, k plus n should be replaced with k plus self dot underscore n, like that. No code. Your solution is correct. Cool. So yeah, we're doing self underscore n, not n itself, right? Because we need to reference the self object of underscore n. Awesome. How long have you been learning to code in Python? Yeah, I've been teaching myself for about 6 months now. I started at the end of May, beginning of June of 2024, and I've been heavily teaching myself for the past about 3 months. Since about September, I've really ramped up my learning and really dedicated myself to trying and continuing to learning. So thank you so much for your comment. Yeah, I started with CS50P. And stuff. Took an entire day just to do one leak code problem. That sounds like it, even with AI help. Yeah. Well, just think about it. Next time you try, it'll be a little bit easier. And next time you try, it'll be a little bit easier. A little bit, right? Until it's a lot of it altogether. Okay, that's the answer to this one. R5.5 underscore key dot py. I went ahead also, you guys, and I made our little reaction into a short for when we solved that recursion problem. I chopped it up yesterday while I was watching a show and after the stream, and so if you guys like that little short, let me know. It was the first time I did one for the channel. Okay, next up, 5.5. Tenmei says, "Are you trying to pivot into a new job?" No, not really. I work as a formulation chemist right now, and I enjoy what I do for the most part. I I have a degree in human biology, but I'm just, I'm not closing myself off to new opportunities and new experiences and to learn new skills. So I think it's often, it would be unwise to, not want to learn new skills and keep up with, technological times and stuff like that. So that's why we're doing this and, pushing ourselves to learn something. And yeah, it's going to be cool. Thanks for your comment. All right, let's continue here. Okay, redo the justification of Proposition 5.1. Ooh, hold on. I'm receiving some errors here. Oh, I think we're okay. The short was great. Awesome. You guys liked it. Cool. I was really excited when you inspired me and I saw the recursion problem by myself. That's really awesome, Wing Hong. I'm super proud of you. That's great. The short was hilarious because of your reaction. Yeah, I figured we should capture that reaction. It would be pretty funny. Okay, let's continue on here. So redo the justification of Proposition 5.1, assuming that the cost of the growing array from size k to size 2k is 3k cyber dollars. How much should each append operation be charged to make the amortization work? Ugh, this one's, I don't know. I didn't really follow along with the cyber dollars question that much, but shoot. This is going to be tough. We need to look at code prop 5.1, 5.2, 5.1. Okay, so this is prop 5.1. Let S be a sequence implemented by means of a dynamic array with an initial capacity of 1 using the strategy of doubling the array size when full. The total time to perform series of n append operations in S starting with S being empty is O of n. The total time to perform a series of n append operations into the sequence starting from an empty sequence is O of n, right? It's proportional to each append that we do. Let's assume that 1 cyber dollar is enough to pay for the execution of each append operation in S, okay? Excluding the time spent for growing the array. Also, let us assume that growing the array from size k to size 2k requires k cyber dollars for the time spent initializing the new array. We shall charge each append operation 3 cyber dollars. Thus, we overcharge each append operation. Okay, so we are charging a cyber dollar for every append operation. Let's assume that growing the array from size k to 2k So essentially, we are having to double the size of the array as every time this gets full. So it'll be full when one item is put in. It'll have 2 slots. It'll be full when the second item gets put in. It'll have 4 slots. Then you can put in 2 more items. Then it gets doubled. Then you can put in 4. Then it gets doubled. Then you can put in 8. Okay, I see where this is going. Let us assume that 1 cyber dollar is enough to pay for the append. And let us assume that growing the array from k to 2k requires k cyber dollars for the time spent. So that's 2 cyber dollars. We shall charge each append operation 3 cyber dollars. Thus, we overcharge each append operation. That does not cause an overflow to the cyber by 2 cyber dollars. Think of this 2 cyber dollars profited in an insertion that does not grow the array as being stored within the cell. I'm just not following this analogy that well. Like that's what I'm having trouble with. Is this analogy is pretty poor. It's just I don't get what's happening here. I'm going to copy this into Mr. Almighty Orb. I am having trouble understanding the analogy between dynamic arrays appending and cyber dollars. The analogy between dynamic array appending and quote cyber dollars is designed to simplify and explain the concept of amortized analysis, a way of averaging the cost of operations over a series of events to understand their overall performance. Let us clarify this analogy step by step. The dynamic array growth problem. Appending an element. When appending to a dynamic array, if there's space in the array, the operation is fast, O of 1 time. If the array is full, it needs to be resized, doubled in size, which takes longer, O of n for copying all n items to the new array. Challenge. If we look at the cost of individual operations, some seem cheap, O of 1 for the appends when there's space, and some seem expensive, O of n for the resizing. The goal is to understand the total cost over many operations, okay? The cyber dollar analogy. The analogy assigns a fixed cost of 3 cyber dollars to every append operation. Whether or not it triggers resizing, these quote cyber dollars are used to explain how resizing is paid for, using the extra funds during cheaper operations. Okay, key ideas in the analogy. Each append operation directly costs 1 cyber dollar for the actual insertion. Saving or resizing. When an append does not require resizing, the operation profits 2 extra cyber dollars. Thus, the 3 charge minus 1 we used. The operation profits 2 extra cyber dollars, right? The extra dollars are metaphorically stored in the newly inserted element. Paying for resizing. When resizing occurs, it costs 2i cyber dollar, 2 to the power of I cyber dollars. This is a typo. It should be 2 to the power of I cyber dollars to copy all elements into the new array, where 2 to the power of I is the size of the full array before resizing. The cyber dollars saved in the last 2 to the power I elements, each contributing 2 cyber dollars, are used to fully pay for this cost. Why does this work? Every time the array doubles, I think it's 2 to the power of I. Okay. The 2 extra cyber dollars are charged for each append, or metaphorically stored within the cell of the array. For example, when the array size grows from 2 to the power of I minus 1 to 2i, all 2 to the power of I minus 1 elements from the previous resizing still have their saved 2 cyber dollars. These savings will fund the next resizing. Okay. Resizing is fully funded. When the array size grows size 2i, resizing to 2i plus requires 2i cyber dollars. The required 2 to the power of I cyber dollars are already stored in the 2 to the power I elements added since the last resizing. Thus, resizing is always prepaid by the saving from prior appends. Every single append is charged 3 cyber dollars. The actual cost of appending without is just 1 cyber dollar, so the extra 2 accumulate over time. These savings cover the occasional expense resizing operations. So what's happening is, from my understanding, is when we are dynamically resizing arrays, we are, pre-taking in memory or paying for it in memory or something in the form of cyber dollars, whatever this represents, cyber dollars. So as we append, it only takes 1, it's constant time, but because of the average over the total amount of operations, because we occasionally have to resize the array double each time, right? It's technically like each cost taking 3, right? And so on average, I got you. Okay, interesting. So redo the justification from Prop 5.1, assuming that the cost of the growing array size from K to size 2K is 3K cyber dollars. How much should each append operation be charged to make the amortization work? So if we are doubling, rather than going up three cyber dollars, rather than charging 3 cyber dollars, um, so what does this problem actually, am I missing a power in the problem here? No. Growing the array size from K to size 2K is 3K cyber dollars. How much should each append operation be charged? So our justification requires K cyber dollars. So we're changing from requiring K cyber dollars to arriving 3 times the K cyber dollars. So we'd need So if it required 3K cyber dollars, 3 times the amount to initialize the new array, we would need to charge not 3 cyber dollars per append, but 9 cyber dollars per append, 3 squared, or 3 times. Okay. So if tripling the cost for increasing the array size from K to 3K, would we also need to triple the cyber dollar cost of each append by, each append? No, you wouldn't necessarily need to triple the cyber dollar cost for each append operation. Instead, the cost per append needs to be carefully recalculated to ensure the amortization scheme still works under the new resizing cost of 3K cyber dollars for doubling the array size from K to 2K. Amortized analysis, how much needs to be charged? Each resizing costs 3K cyber dollars. To ensure that this cost is covered, we need to store enough cyber dollars during the appends leading up to the resizing. If the array size doubles from K to 2K, then there are K new elements inserted since the last resizing. Each of these K elements must contribute enough to cover the 3K sizing cost. Each append must contribute extra cyber dollars per append. Total resizing divided by the number of new elements. 3K divided by K is 3. In addition to the 1 cyber dollar used to append itself, the total cost per append becomes 4 cyber dollars. So you just need to add 3 to the So we would just need to, rather than charging $3 for each cost, we'd have to increase it to $4 for each append. $4. So it is, we were charging $3 cyber dollars. Now we are charging for an over $3 per append with an overage of 2. And now we are charging 4 with an overage of 3. Exactly. So each append was charged $3 cyber. $1 directly for the cost, 2 extra cybers to save for future resizing. The resizing cost for doubling the array from K to 2K was K, and the saved $cyber for the amount of K appeared fully. Appends fully. New scheme. Resizing equals 3K. Now we is now charged $1 cyber for each direct cost of the append, and 3 extra cyber dollars for the overage. The resizing cost for doubling the array from K to 2K is now 3K. The saved cyber dollars the overage corresponds directly to the resizing cost per element. Initially, when resizing cost was K, the overage was 2 cyber dollars. Now that the resizing cost is 3K, the overage becomes 3 cyber dollars. This ensures that the cost of resizing is always pre-funded. Got you. This would be 1 cyber dollar for the O of 1 append with 3 cyber dollars extra per cell in the new array for to cover the future cost of increasing from K elements, K cells to 2K cells, doubling the array size. Right? Okay. Yeah, me too. Cyber dollars confused me as well. It's not a very good analogy, in my opinion, or way to explain it. I feel like it could be explained with a much simpler, or a much more simple example than the one provided. But we are just doing our best with what we're given here. Thanks so much for coming in tonight. DX Bangs, how's it going? Thank you for joining. How are you doing? Welcome. Okay, let's continue on here. R5.6 underscore key dot pi. One, two, three. Okay, our implementation for the insert for the dynamic array class as given in code fragment 5.5 has the following inefficiency. In the case when a resize occurs, the resize operation takes time to copy all of the elements from an old array to a new array, and then the subsequent loop in the body of the insert shifts many of those elements. Given an improved implementation of the insert method so that in the case of a resize, the elements are shifted into their final position during the operation, thereby avoiding the subsequent shifting. Oh boy. Oh boy. Anybody following along with that? Okay. Let's try this out. Okay, code fragment 5.5. Okay, let's look. 5. 5 is 5, 4, 5, 5. Here is 5, 5. So what we're saying is, as a following inefficiency, in the case when a resize occurs, so if n is equal to the capacity when a resize occurs here, the resize operation takes time to copy all of the elements from the old array to the new array. For j in range of the n value all the way to the value provided at k, we're going down by 1. We're going to take the value and shift it equal to the value at 1 less than j. So let's say that we have an elements of a list of 5. So we have a list with is equal to 5 elements. Let's say it's 5, 3, 6, 8, 2. Okay, so our n is equal to 5, which is the length of the L, which is equal to 5, right? So if we were wanting to resize, let's say we're wanting to insert at index value 4, right? So this is, well, let's make the index here. This is going to be I is equal to, this is going to be 0, 1, 2, 3, 4, right? And then index values j, which is the reverse, are equal to -5, -4, -3, -2, and -1. Okay? So these are the reverse indexes. And these are the forward indexes. Okay? With the total length of 5. We are doing a for loop. Let me grab my whiteboard. That's going to be helpful here. Ooh, whiteboard. Okay, so we have a list which is equal to 5, 3, 6, 8, and 2. Let me make sure. All right. So if we were wanting to run this insert function, right, if we are at capacity, we double and resize. Right? So this list is at capacity, technically speaking, right? Let's just say it is with 5 elements. So then this list gets multiplied by 2 for capacity and becomes L is equal to 5 5, 3, 6, 8, 2 with blank 1, 2, 3, 4, 5. Like this, right? That's what happens. Then we say for j in the range of self minus the range, so j is going to be created, and it's going to be in the range of n, so it's going to be 5 to k. So where were we trying to insert k? Let's say that we're trying to insert k is equal to what, 4? So we're trying to insert at the last element point, or no, let's say it's let's make it 3. So we're actually shifting stuff down, right? Or it would be with 4, but let's make it 3. So k is equal to 3. So j is 5. Oh no, hold on. J is a looping value, so it'll shrink down. So j is 5 to 3 with a skip of -1. So j is going to be equal to 5, 4, and that's it. So at this point, we're going to say self of the array at index point 5, so which will be right here. No, sorry. Okay, yeah, so actually it will. So it'll say self of index point 5, right, in our new array. We're working with our new array here. So self of index point 5 is going to equal the value at the previous, this value here, j minus 1. So j minus 1 is equal to 4, which is here. So we're going to take this value and set it here, 2. Okay? And then we take j at k, which is k equals 3. Oh, but then it's also going to take the 8 and shift it to here. So now 8 becomes here, gets removed from here, and the value at k goes into here. Okay, I see what's happening. Interesting. Okay, so now what do we need to do though? We need to, in the case where a resize occurs, the resize operation takes time to copy all of the elements from the old array to a new array, and then subsequent loop of the body inserts shifts many of those elements. Give an improved implementation of the insert method so that in the case of a resize, the elements are shifted into their final position during that operation, thereby avoiding the subsequent shifting. So when we resize, give an improved implementation of the insert method so that in the case of a resize, the elements are shifted into their final position during that operation, thereby avoiding the shifting down below. So in the event of a resize, we want the shifting to take place in the resize as well. So we have a def insert self k and some value. We'll say if self dot underscore n is equal to self dot underscore capacity, right, we're going to resize double the capacity. And then we're going to say for j in range self dot underscore n k and then -1, we're going to self underscore array at index value j is equal to self dot underscore a at index value j -1. And we're going to say self, we're going to reassign the value of self a index value k is equal to value self dot underscore n plus equal 1. Okay. So how can we, within the capacity here, the resizing, handle the shifting as well? Insert so that in the case of a resize, the elements are shifted into their final position during that operation. So we resize times 2 on capacity of the array itself. So at this point, we would need to say could we just copy this loop here for range and n? So self of total data points k -1. We're going to assign this, and then we'll say here we need to say else do this. But we need to be saying every time we need to be increasing what can we say while oh, this is tricky. I'm going to take this, walk me through step by step, no code. The inefficiency described in the insert method arises from the fact that it performs 2 separate operations when resizing the array. A resizing operation copies all elements in the old array to the new larger array. The shifting operation moves elements in the new array to make space for the elements. Identify when resizing is necessary. Check if the current array has reached its capacity. If yes, proceed with resizing. Otherwise, perform a simple insertion. Allocate a new array size during resizing. When resizing is required, allocate a new array that is larger, typically twice the size. That's what we're trying to figure out right now, is how we're supposed to shift and resize at the same time. Combine copying and shifting. As you copy elements from the old array to the new array, decide where each element should go. Okay. So we'll increase the capacity. So what if we say as you copy elements from the old array to the new array, so this copies the old elements from the old array to the new array. Leave a gap at the insertion for the new element. So we're going to double the capacity. We are then going to loop over every element in the previous array. We need to set the value of k here. So a at index value j will be equal to the previous value. So if I take this, your code snippet demonstrates logic for inserting an element into a dynamic array. Here's an example of what's happening. No, stop, no code. The method first checks if the array is full. If so, it resizes the array by doubling its capacity. However, the resizing is separate from the insertion process. Shifting elements. If no resize is required, it shifts all elements starting from the insertion index to the right by one position to make space for the new value. Inserting the value. After the space is created, the new value is placed in the correct position and the size of the array is incremented. How to improve. Combine. During the resize operation, directly copy elements to their final positions in the new array. Hey, Taylor Resume plugin. Yeah, I'm reading aloud data structures and algorithms in Python on the right side of my screen. I provide a copy of this PDF. It's just a textbook I found online in my Discord link below. So if you'd like access to that, feel free to join down below, or also just look it up online for yourself. Okay. Combine. During the resize operation, directly copy elements to their final positions in the new array. So we need to copy all the values from the previous array. If the capacity, we set the array equal to the resize capacity, and then we say n is the length, the capacity. We say for value in self dot underscore a, right? We want to access every value in self dot underscore a, but we want to first say access the index value for each of those. So for where k was given, so for j in range of self underscore n, so from the end of the array, or the length of the array, the last element, to k. So k is going to be exclusive here, meaning we don't want to include up to the index value of k provided. We want to go down by -1, just like before. We want to then say we want to do this shift for j in range, do the shift so this gathers the index values from the end of the list, so it would capture index values 4 and 3 if we were inserting at. If we were inserting at 2, k would be a value of 3, right? Okay, would be a value of 2, meaning that we would be inserting at 2, so we need to move 2, 3, and 4 down. Hey BCA, how's it going? Yeah, we're just solving this problem here from end of chapter 5 of data structures and algorithms in Python. We've been reading aloud all of these chapters on stream so far, and then solving all of the problems at the end of the chapter. So we're solving this one here. We're trying to implement, so this is getting all the, this will take index 5, this will take index value 5, included. So we don't want to do index value 5 because we only go to index value 4, right? Index value 4 is our highest index in this list. So if we did index value self 5 here, it'd be -1. So we want to do 4 to 2. Four, 3, 2. K would be excluded here. Or sorry, in the range function, k would be excluded. 2k, so it would be 2, 2, position 2, not including 2. We need to do no, they just do n. So for j, we need to include k. We need to leave a gap for k. I guess they do that here because they obviously set the value of at index k to the value provided. So we do this function, we do this call, we set every value of a at that j equal to the new value, and then we insert here, here, like so. Let's try that. This provided information still separates the resizing and the element shifting into two distinct operations, which is inefficient during a resize. Let's walk through this, what's happening, and how it can be optimized step by step. Check for capacity. If the number of elements is equal to the array's capacity, the array size, we're creating a larger array. Okay, we did that. Boom. After resizing, if needed, a loop shifts elements from the last element down to their insertion point K, moving each one position to the right. While copying elements decide on their position. Okay, while copying elements decide on their position. Skip the insertion index to elements before the insertion index are copied directly to their corresponding positions in the new array. Okay, so we double the capacity for value for index in range of 0 to n minus 1, right? We want to, for I in range of n minus 1, right, what we'll do, that is going to take all the, no, up to, not n minus 1, up to k, right? We want to include up to k. So let's say if 6 is the value we want to remove, so k is equal to 2. Okay, k is equal to 2. We're inserting at value 2. We're going up through here, so up to k, and copying those numbers over. Then we need to go take the range of the values from k onward and copy those forward into the new array. Okay, so for I in range 0 up to k, so this will be 5 and 3. So 0 and 1, we're going to take the self dot underscore a at index value I but where's the, I'm confused about where they're handling all the other numbers being copied over. Right, this is just handling, right, if I remove this else statement is just handling from the total length all the way to k and shifting those elements, right? So by nature, the elements that appear to the left of k will remain in the array, but I thought we are creating a new array. So we have to copy all of the elements over, which isn't being handled here. So for I in range 0 to k, we take when an array is resized, do all the elements remain in the original? Have to be copied to the new resized array? Because I do not see where that is taking place in the code I provided. it is only copying elements to the left or to the right of position index K. You're correct to question whether all elements are being copied to the new array during resizing. In the code you provided, the processing of resizing, creating a new array, and transferring elements from the old array is abstracted away and not explicitly shown. The resize method is assumed to handle the copying of all elements from the old array to the new one. Let's clarify how resizing typically works. Allocating a new array. When resizing is triggered, a new array is created with a larger capacity, usually double. Copying. All elements from the original array are copied to their corresponding positions in the new array. After copying, the dynamic array updates its internal reference to use the new array. This process ensures that the entire array's contents preserved. In your code, where resizing presumably creates a new array and copies all elements, the copying operation would be defined inside the resize method, which you haven't provided. After resizing, the loop shifts elements from self_k. Okay, so it's happening inside the resize element, I guess, is those elements are being saved over. So what would be the solution in this case? Okay. To address the inefficiency described, this eliminates the need for a for loop, separate loop to shift elements after resizing. No, that's what I'm kind of trying to deduce here. Is the question is kind of vague. Combine and shift. When resizing the array, instead of copying all elements to the original positions in the new array, copy elements before the insertion. Copy elements before the insertion directly to the new array in their positions. Leave a gap at index K for the new element. Copy elements from the inserted K directly to their respective positions, one index to the right. I don't get why would we not just loop? I don't get how we would not use a loop to do this. You're absolutely right. A loop is still required to handle copying and shifting during the resize. The key improvement is how we use the loop. Instead of looping twice, once for resizing, instead of looping twice, one for resizing, one for shifting, we can use a single loop to handle both operations at the same time. Why a loop is needed? So would we say resize returns the array with a capacity that's too large with the original values in it? Anybody have, this is really tricky. It's like, should I ask it to show me? Like, I really don't know. Like, I don't even know. Like, it's handled here. in this loop. Why couldn't we just take this loop and is this not what it is? Is just take this loop and put it here and say, okay, we need to take the values and shift them forward? I mean, the other thing you could do, I guess, is take a slice of the array from k forward. You take a slice of the array from k forward and shift elements and concatenate the arrays together. Come on, what's going on here? Oh boy. Using a slice concatenation could work conceptually, but it isn't typically the most efficient approach due to the overhead involved with slicing. The loop-based approach directly operates on the array and reside on the reside or the resized version without creating intermediate slices. So I'm going to ask it. I usually don't ask it, you guys, to show me code, but this problem is pretty vague. I really don't understand how we're supposed to combine. This is suffice. This is what we're supposed to put here, though, I feel like. Show me how it would be implemented. Resize the array when needed. Combine the copying and shifting of elements into one step during the original process. Check for resize. Allocate a new array size 2 times the capacity. Loop through the old array. Okay, so it's wanting us to remove the resize function here. And create a new array. So new array is equal to 2 times the capacity So new array, we need an array with values none, that's times 2 times the self of capacity, right? We're going to say for so I'm going to copy this over so far. This is what I have so far. You're off to a great start. Whether the resize is needed, it's starting to handle the creation of a new array size when the capacity is exceeded. Let's build on what you've implemented. Complete insert method step by step. Bro prefers every language. Was that not just resize array? I feel like the resize array function was just, that was it. It returns a list with the resized array. Let's see here. Insert time import here, dynamic array, resize function does this. We take in a value C, a capacity. We make array for capacity. We return an array. And then we apply every value. Okay, so this returns the copied list. Okay. So ChatGPT didn't know that. We need to let it know that. The resize function returns a new list with capacity 2x and all the previous elements copied. Thank you for the clarification. If no resizing is needed, the array has space. You need to make room for the elements. Write down. Okay, cool. That's literally what I have here. So then, what happens if I give it this? So if we create 2 for I in range, so we create the new array, we copy all the elements over, we insert the new value at k, we take an index value from k forward and append forward. Yeah, that's exactly what I was doing. Okay, oh my gosh. Sorry you guys. Like, ChatGPT didn't. This is the struggle with AI and using this, is sometimes it can lead you down rabbit holes. You know, it's a great tool for other things, but sometimes it can lead you astray here, and you need to use caution and really work through it. But we were doing the right thing the entire time. Yeah, we're supposed to do this. So the resize happens. It doesn't want us to call a resize function. It wants us to make an array 2 times the size of capacity, just like we were doing. Equals none. That was 2 times the size of capacity. Right? And then it wanted us to do the loop from up to element k, insert those elements like the previous function did. So it said for I in range up to k, right? We're going to take our new array at index I and set it equal to the self.old array a at index I. So we're just copying over all those elements like we were doing in our previous attempts at this. To self.resize is an O of n task, and you are doing another O of n operation for shifting. Just copy and shift in the same loop. Yeah, that's exactly what I was thinking, right? Like, that's initially what I was thinking, is if the resize, is ah. So if we have the resize, can we not just take this loop here, just put it here, and then we'll have to set this here. Like, Ben, is that what you mean? Self-resize is an O of n task, and you're doing another O of n operation for shifting. Just copy and shift in the same loop. So if insert at k is 0, that would be the worst case, right? Yeah, insert k 0 would be the worst place. Yeah, it would be the worst case scenario. So you're saying that we should just resize because this was my original approach. This is what I was thinking earlier, where we just create the new array, go up to k, assign all the values up to k, leave a space, assign k, and then assign all the values after k. And then say the new array is equal to a at this point, and the capacity is equal to 2 times the previous capacity. You're right, make a new array and populate it. Okay, exactly. Okay, let's try that. Just like before. So the new array would equal to a list with values of none inside of it. How many none values are we going to do? Well, we want to have 2 times the capacity, the current capacity, right? We need to loop over and find the index values in the range up to the k value provided, right? If we want to insert at k, we need to find all the index values up to k. We are going to assign the new array values of those index values from the old array values at those indexes, right? Up to k. For I in range k. New array. Cool. Then what we need to do is we need to assign the actual value of k at that place, because we are up to k now. We went up to k, not actually at k. Now we need to assign k and then assign k forward. So, or forward from k. So we'll say new array at index value k is equal to value, right? And then we're going to say for I in the range of k all the way to the end of the array, or the end, not the end of the array, but the end of the previous array, which was the full array, or the end of the current data set, which is n, right? We are going to assign new array is equal to I plus 1. We need to shift all of the indexes down for all the values at self._a at index I, right? At this point, we have shifted all of them down, and we need to set the new array equal to the, we need to like, reverse the context of the variable names. So self dot the previous array, or the array itself, is now equal to the values that are in the new array. So we're overwriting the a array with the new array that we created. And then we need to update the self dot capacity for the previous, for the new updated capacity. So then this will have to go inside of the for loop here, and then we'll increase 1 at the end by n. Okay. All right, cool. So that will go here, boom, like so. Your method looks great. You've correctly managed. Awesome. Oh, wow, okay. Does that none times n create a pi list or an actual array? I'm not exactly sure. From the context of this book, we've been taught to, I know you can't like create, there is no array method in Python, like there is in like C or C++, things that where you can create actual arrays in the system's memory. Python handles that, I believe, on the back end. And so this was just in the context of that dynamic array class we have created, which does the same dynamic array processing on the back end that Python handles for us, through its like compiler, right? Rather than it being a low level or a direct level language to the hardware of the computer. So this is just in the context of the dynamic array class that was created, which models or mimics that of what's going on in the compiler and stuff in C and C plus and things like that. I think if that's what I don't know. I'm a noob, so hopefully I don't know. In this context, I believe it creates like a dynamic array because we're working with that dynamic array class and insert. And on the back end, I think Python does some sort of modeling after that. So yeah, I'm not sure though. Edward 404, awesome. Thanks so much for coming in. Hello, new subscriber. Glad to meet you. Oh, that's so awesome. Thanks so much for coming in. I'm so glad we could link up and find each other. And yeah, this is a great place for beginner programmers to come in and learn together, from a beginner's point of view, and really see things from a like a realistic point of view and approach of learning here. Awesome. Welcome to the stream. Yeah. Thanks so much for Ben and Script and all you guys for helping me out, and dash 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 dash. Okay. All right, let's see here. What is the next problem? Should we do another one, or should we move on to maybe some reading and then jump into the project? Or what do you think? Let's see here. 5.7 says, let array A be an array of size greater than 2 containing integers 1 to n minus 1, including inclusive, with exactly 1 repeated. Describe a fast algorithm for finding the integer a that is repeated. Okay, this one might be kind of fun to try real quick. Okay, let array A be a size of n greater than 2. So we have a value of 4, we have a value of 3, right? And we have a value of 7, let's say. Containing integers from 1 to n minus 1. Containing integers from 1 to n minus 1. So if n is 3, so let's say n is equal to 5, because it's greater than or equal to 2. So we have to have integers from 1 to n minus 1 inclusive. So 1 to 4. So we can have 1, 1, 3, 4, right? We could have 1, 2, 3, 4 in our list. Including exactly one repeated value. So it'd be like 1, 1, 3, 4. Describe a fast algorithm for finding the integer in A that is repeated. Awesome, Edward's from Portugal. That's really cool. That's so cool that we're getting such a reach on this channel to a lot of different, areas of the world. I want to learn HTML. Not going to lie, I've never touched HTML. It's like Markdown. Awesome. Yeah, HTML is similar to Markdown in terms of like using, hashtags and things like that for headers, bullet points, creating bullet points. But I've seen a lot of people also just use raw HTML to create like actual programs. I think it's raw HTML and JavaScript there where they've been able to actually just, create pretty elaborate designs, and not designs, but just mathematical programs within the browser, which is pretty cool. Okay, so describe a fast algorithm for finding the integer in A that is repeated. Describe a fast algorithm for finding integer in A that is repeated. So we want to find out if 1 is repeated. Now, obviously, you can save the value of 1, all unique list in a tuple. Like, what if we saved all unique values in a tuple? We iterated over every value, did a comparison if it was unique saved in a tuple. And if it was not unique, return the value that's not unique. What algorithm would that be? Would that be a fast algorithm? That would be, we'd have to do an iteration up to n. So you could technically have, let's say that the 1 was, this was 2, and this is 1 over here, and then the 4 is over here. So the worst case scenario is you don't find the repeat until the very end. So your worst case scenario would be an O of n time. So it would be a linear algorithm that checks every value and returns the value that's repeated. So that would be an algorithm. So option 1 would be iterate over every value in the array, saving save the first value of the array, saving I equals 0 in a tuple, comparing every next value with value in tuple. So this one actually you'd have to iterate over every value of the tuple as well. Because if it saved the 1, and then it saved the 4, and then it saved the 3, it would have to then iterate over the tuple of well, and this would be O of n squared time actually. So this would be a quadratic function. So right, if I were to iterate over every value in the array, saving index 0 in a tuple initially, comparing next value with the value in the tuple, saving unique values in a tuple, comparing values with values in the tuple, returning a duplicate. So this would run, should be O of n times O of n for a O of n squared time. So this one's not that fast. Oh, not that fast, not that fast. So, what do you guys? Tuples are immutable, meaning that we can't change any value. And we can't. Can we iterate over a tuple? Yes, you can iterate over a tuple. Yeah, so the whole tuple is the fact that they're all unique. Right. So that's why we would use a tuple, is because we define unique elements. What would be another algorithm that maybe is a little bit better, do you guys think? How does this live stream work? Do you accept ready-made answers or suggestions? Yeah, so I for those that are new and don't know and are following. Oh, did I mean a set? Yeah, sorry. Tuples versus sets. I get these confused all the time. Multiple are immutable, meaning once tuple is created, it's going to be changed, added, or removed. Sets are immutable, meaning you can add or remove elements. Are ordered. Tuples are ordered. That's why. Okay, so I thank you for the clarification. I completely go back and forth and mix these up over and over and over again. I don't know if anyone else does this, but I cannot for the life of me keep these two distinct in my head. It just they always flip-flop their properties. Is there any sort of like acronyms or secret like hints or anything people have used to ordered, tuple, ordered. Is there any sort of like trick that mnemonic or something that we can use to remember this? I always just can get these two mixed up. So in a set, comparing next values in the set, returning a duplicate if found. Right? So that like we can define a function like this: def dupe found takes in an array. We would say for index value in the range length of array, right? We would say iterate over the array, saving unique values in a set. For value in the range. No, so we need an index value. So for value in array, so we need to just do first a dot append we need to create a set. Uniques is equal to a set, right? We will go we will add in the first value of the array into the set. So array if length of array is equal to or is greater than or equal to greater than or equal to 1, we want to take uniques dot add for the set value array index 0, right? We'll say for value in A, so for value in A, we're going to take that value. So actually, if we're going to say for value in A, I don't know how it would be faster than O of n. Wouldn't you have to check all values until you come across a duplicate? Yeah, that's what I was thinking, right? Is you'd have to first iterate over all the values in the array A itself, and then iterate over all the values of the set and do the comparison. So how can we set this up? We have a uniques, we have a set here with uniques. We establish for value in the array right? We are going to, if val not in uniques, we're going to uniques.add val, else return val. Then we'll need to say here, if length of array is greater than 1, do the following, right? If the length of the array is greater than 1, we know that we can have a potential to find so add all the value. So let's say, boom, 1 is our first value in our array. Our array is greater than 1. So we're going to loop over 1 is representing the value. That's not in our unique, so it's going to be added to the unique set. Okay, we move on to our next value, 2 or 4. That's not in the unique set, so that gets added. 3, that gets added. 1 is in the unique set, so we return the value. Now what happens if elif elif val in uniques, right? We'll return value, else return none. Right? So if we call this function now, print dupe found for A_1. 1. Perfect. If you have a sorted array, you can do it in log n via binary search, I think. Or maybe n log n. I was going to say that as well, but sorting would also add to the time complexity. Yeah. Interesting. That's a good point. So, right, you guys, if we had a sorted array, we would immediately know that the duplicate value would be found perpendicular. Is it perpendicular? Adjacent. My geometry. Whoa, geometry way out of here. Adjacent to the value, right? If the values are already in order, right? The duplicate values are found adjacent or directly next to the value, right? So this would be assuming that the array is unordered. Right? Assuming that the array is unordered, we can iterate over every value in the array, saving unique values in a set, no dupes allowed, comparing next value with the value in the set, returning a duplicate if found. What about this? What about this? What about if we made this a little bit more like Pythonic? Hold on. Let's do def dupe underscore found for array A. Let's say uniques is a set, right? We say if the length of the array is greater than 1, we want to try and loop. We'll append it except if we get a value error right? Except if we get a value error, we want to return none. Return val. So what I did here, I'm not sure exactly if it'll give us a value error. That's just my assumption, right? But if we try and add values to a set, and if that value is already there, Python will raise a error, by nature. So can we catch the error that's raised, value error? What error is raised when a dupe int is attempted to be added to a set? When you try to add a dupe integer to a set in Python, no error is raised. Instead, the set simply ignores the attempt to add the duplicate and maintains only one instance of the value. The set doesn't allow duplicates, so the second is ignored, but no exception is thrown. Oh. This would not work then. Oh, dang. So if I was relying on a try except for catching dupes in a list by adding to a dupes set, nothing would happen. Correct. If you're relying on a try except block to catch duplicates when adding to a set, nothing would happen because adding a duplicate to a set does not raise an error. Set automatically handle duplicates silently by ignoring the second occurrence of an item. Dang it! Except exception as E print dupes. In this case, when 2 is encountered. Yeah, that wouldn't work. Interesting. The simplest way to calculate the expected sum from 1 to n minus 1, then calculate the sum. Add up all the numbers in list A. Finally, subtract the expected sum from the actual sum and find the missing number. Gotcha. Yeah, that sounds great for doing the expected sum from 1 to n minus 1. Awesome. So this is how I am currently handling dupes. Your current implementation of the dupe looks mostly correct for identifying the first duplicate in a list. However, there are a few small points that could be adjusted. Unnecessary elif value and uniques check. Once you already know value is not in the set, you don't need to check again. Else block, since you return early in the elif branch when a duplicate is found, there's no need to return else at the end. For value if uniques, if val in uniques return. Yeah, so we could do the opposite of the Boolean. So if val in uniques, we could return val. Else we're going to just uniques dot add the val in the else statement, and then we're going to return none here if the length is that and if we don't meet any of these conditions. So we still get 1 here. Correct. Perfect. Like so. Your updated code looks great. Efficient. It's great. Wow, that's a nice solution. Leveraging the fact that the elements are integers. Which one are you referring to? For the exception, the try except. I know, I thought that would work, but it doesn't. If we could leverage the exception that's being raised, but I guess sets handle the exception silently, unfortunately, if that's what you're referring to. So, assuming that the array is ordered, right? We can iterate over values in the array, checking, saving index values as well, and checking adjacent indexes if adjacent value slash index is equal. If so, return value, else continue iterating. The method of using sum all elements. Oh, gotcha. The simplest way is to calculate the expected sum from 1 to n minus 1. Then calculate the actual sum. Finally, subtract the expected sum from the actual sum to find the missing number. Okay. So you're saying that if we have some array with these values of n equals 5, the maximum sum we can have in this array for n equals 5 would be a values of 1, no, a values of, oh, if n equals 5, so we're missing an array point here. We need an array point. So this would be 2. So the maximum value of the array size we can have is this, 4. So it'd be 1, 3, 6, 7, or sorry, 3, 6, 10, 14. 14 would be the maximum sum of this array. 8, 11, 13, 14. So 14 would be the maximum sum of this array, meaning that n times 3 minus 1, that's how you could get 14 from n. So let's say n was 6, meaning that we can have a 4, a 5, and a 5. This would be 10, 14, 17, 19, 20. 6 times 3 is 18, minus 1, that'd be 17. So that would not work. Simplest way is to calculate the expected sum from 1 to n minus 1. Interesting. So let's see what the Jippity has to say about this guy. To solve this problem efficiently, we can use the Floyd's tortoise and hare algorithm known as the cycle detection algorithm, which finds the repeated integer in array in O of n time and O of 1 space. This approach works because the array contains integers from 1 to n minus 1 with exactly one repeated value. Given the array of size n with between 1 and n minus 1 inclusive exactly one repeated integer, the challenge is to identify the repeated number efficiently. Explanation of Floyd's tortoise and hare algorithm. The idea is to treat the array as a linked list, where each element points to another index in an array. Since there is exactly one repeated integer, this creates a cycle in the linked list. The algorithm uses 2 pointers known as the tortoise, slow pointer, and the hare, fast pointer, to detect the cycle and find the repeated element. Phase 1. Detect the cycle. Use a pointer, a tortoise, slow pointer, and a hare, fast pointer. Initialize a tortoise at O0 and a hare at A of 0. So at the first point, move the tortoise by 1 step at a time. Tortoise equals a tortoise. Move the hare by 2 steps at a time. The tortoise and the hare will eventually meet at the same point in the cycle. Phase 2. Find the start of the cycle. Once the tortoise and the hare meet, reset the tortoise at the beginning. Now that we move the boat. So we set them to the start. While true, tortoise is equal to A of tortoise. I don't get this. So we're setting The tortoise slow pointer and the hare fast pointer. Initialize tortoise at the first value and the hare at the first value. Move the tortoise by one step at a time. Tortoise is equal to index at tortoise. So tortoise will move by one every time at index of tortoise. Well, tortoise equals A index 0. So A index 0 is being placed here, and A index 0 is being placed here. How is that moving up one at a time? GPT is overcomplicating. Yeah, I feel like that is definitely the case here. Let's go ahead. Well, we haven't even learned about this algorithm yet in the book at all, so I think it defeats the purpose to try to learn that right now. Okay. Interesting. Okay. I'm going to ask though, is my algorithm, oh, whoops, is my algorithm in O of n squared time? Is not, but it's an O of n. Checking values is unique. One over the loop. List, not a set, and checking members with the in operator. Checking members in a list takes O of n time because so if you check membership for each element in a list size of n, that would result in an O of n squared time complexity. Since you're using a set, an average time complexity for checking membership and adding elements is O of 1, which makes your algorithm run in linear time. So I thought I have to iterate over the set at each check of val in set. You're correct to think that the membership checks involves looking through the set, but there's an important distinction to make. When using a set in Python, the time complexity of checking if a value is present in the set is O of 1 on average, not O of n. How sets work. Sets in Python are implemented using a hash table, also called a hash map. When you perform an operation like val in uniques, Python hashes the values and checks a corresponding bucket in the hash table. This operation is very fast with an average time complexity of O of 1 because the hash table allows constant time access. If there's a hash collision, two values mapped to the same hash bucket, the set handles its effect efficiently, but it's still greater general operations in O of 1. Okay. Okay. So accessing values in a set or, determining values are in a set as a constant time operation similar to like a dictionary in a sense. Okay. Cool. All right. Yeah, thank you for that, Legendowski. Appreciate your help with that. Cool. All right. Let's go check on the. Okay, good. My girlfriend made it back to her place, so let's just check in. Awesome. Great. All right, what's next, you guys? Should we start reading chapter 6 here. Chapter 6 goes to pages 229 to 250. So about 20 pages, not bad. Maybe we could get through about 4 or 5 today. Yeah, let's go for it. I want to. We need to keep moving here. Got to keep moving to stay on to our schedule of learning here. We need to get through this book here. Chapter 6. Okay, chapter 6 gets notes of chapter 6 notes.md. Perfect. And then how did we set up these notes last time? We did chapter 5, we did definitions at the start, and then we did headers like that. Okay, definitions, and then we did headers like this. All right. I'm just over here being entertained by this, but also thinking about what to make in C++. Awesome, yeah. That I can't really input much on that. I've never ever seen a C++ line of code in my life, so I'm gonna grab a refill of drink. I'll be right back, guys. All right. Thank you for waiting, you guys. Sorry, I was just grabbing a refill on my drink, and my girlfriend made cookies yesterday, featured in the stream yesterday, so we got one of those. All right, cool. So moving on here, chapter 6. We have a couple more problems in chapter 5 to complete, but I want to kind of continue on and learn them while we can. All right. Let's keep it going. All right. Chapter 6. Stacks, queues, and dequeues. Queues and dequeues. Okay, cool. All right, stack 6.1. Here we go. I'm excited. Let's go, you guys. Let's learn. One step closer to being done with this book. Here we go. A stack is a collection of objects. We'll go, here goes stack. A stack is a collection of objects that are inserted and removed according to the last in, first out LIFO principle. Right? A user may insert objects into a stack at any time, but may only access or remove the most recently inserted objects that remain at the so-called, quote, top of the stack. The name, quote, stack is derived from the metaphor of a stack of plates and a spring-loaded cafeteria plate dispenser. In this case, the fundamental operations involve the pushing and popping of plates on the stack. When we need a new plate from the dispenser, we pop the top plate off the stack. When we need to add a plate, we push it down on the stack to become the new top plate. Perhaps an even more amusing example of is a Pez candy dispenser. Exactly. Which stores mint candies in a spring-loaded container that pops out the topmost candy in the stack. When the sorry, this cookie is really it's got me my my tongue all salivating. Okay, when we push it down on the stack, it becomes a new top plate. Perhaps an even more amusing example is a Pez candy dispenser, which stores mint candies in a spring-loaded container that pops out the topmost candy in the stack. When the top of the dispenser is lifted, see figure 6.1. Stacks are stacks are a fundamental data structure that are used in many applications, including the following. Example 6.1. Internet web browsers store the addresses of recently visited sites in a stack. Each time a user visits a new site, that site's address is pushed onto the stack of addresses. The browser then allows the user to pop back to the previous visit site using the back button. Example 2. Text editors use an undo mechanism that cancels recently edited operations and reverts to a former state of document. This undo operation can be accomplished by keeping text changes in a stack. Leon says, pronounce, quote, deck. DQs are a different thing. Oh, DQs are a different thing. It's pronounced, quote, deck. So stacks, queues, and decks. Like a deck of cards. Not DQs. It's not DQs, it's decks. Okay. Angela, thanks so much for passing by and saying hello. That's all that matters is that you came by and said hello. Hey, thanks so much. I appreciate you coming in. Have a good night. See you tomorrow. It was great to hear from you. Um, yeah, I've never ever seen a line of C++. Like I said, I'm a beginner. I have only been learning for about 6 months, so I've only been focusing on Python primarily. Yeah, if you think about it, a recursive function uses stack for its calls. For each function recursively called a stack is pushed, and then when it's done, it will pop off. Not like a deck, just different pronunciations. Not like a deck, just different pronunciation and different concept. Okay. So we'll say like examples. We have example number 1. It's going to be like a stack of internet web browsers, back button for back button. Yeah, that's fine. And we'll say 2 would be the text editors or the control plus Z or command Z plus Z functionality, right? To undo changes. Push stack.append item, pop stack.pop, peek stack dot index -1 / wait. I have been calling it a DQ all this time. Yeah, that's interesting. It's dex. DQs would have another QUEUE, right? Would have it. Interesting. C++ is a rabbit hole. There's always something more to learn. Yeah, I'm sure, definitely. Just thinking about how you have to manually store memory addresses and stuff seems pretty complicated. I'm kind of taking things for granted here of how easy Python makes things. So maybe one day we'll get into those. Okay. Moving on. 6.1, the stacked abstract data type. Stacks are the simplest of all data structures, yet they are also among the most important. They are used in a host of different applications as a tool for many more sophisticated data structures and algorithms. Formally, a stack is an abstract data type. Okay. Stacks are ADTs. Such that is an abstract data type such that an instance of S supports the following two methods. Let's copy this. Examples like this. We'll come down here like this. Stacks are abstract data types. Meaning that an instance of S supports these. One, S dot pop or push E. This adds element E to the top of the stack S, and two, S dot pop, which remove and return the top element from the stack S. An error occurs if the stack is empty. Cool. So push element will remove or will add element E to the top of the stack, similar to the append, right? Leon says, yeah, dequeuing is a function that manipulates a queue. Interesting. Thank you so much for that clarification, Leon. Ever used React as the front end? No, I haven't. I did a little bit of HTML and CSS in the Odin project, but I never really went too far because I just wasn't really super interested in, the graphical and user aspects of like web pages. It just wasn't something I was so super heavy into. Obviously, it's something I will eventually probably need to understand for creating applications and programs outside of the terminal and the CLI environment currently that I'm working in, and have familiarity in. But I've been more kind of focused on like the data aspects, like understanding how to manipulate data, what you can create with data, all those kinds of things, rather than maybe creating more like artistic and visual representations of programs. So it's just to each their own. There's nothing wrong with either, right? It's just like in my personal background in a chemist, it just kind of fits more in line with data manipulation and math and things like that. So that's kind of where I'm more interested in. But I'm sure eventually we're going to have to get into things like React and if we ever want to participate in maybe like a hackathon or something, that'd be kind of cool if I live streamed like a hackathon, if the channel got big enough and we went to one. That'd be cool. I don't know. I'd be nervous though. React a few years ago was super punishing. Imagine getting a new update every 2 weeks. If you don't mind, do you live in the US? Hey, BCA Tala, I appreciate you commenting and asking a question. Yeah, no worries. Yeah, I live in the US. No problem. I live over on the west coast of the United States. Chase from space, front end is lame. From my resources that I'm a front end engineer. Oh, awesome. Yeah, I've been more interested in the kind of data and back end and making things work and like the functions behind them is what I've kind of been more enjoying rather than just kind of like the user interactability and stuff. It's still it's obviously important, but each their own, like I said. Thank you guys so much for the participation in the chat right now. Awesome. Appreciate you guys joining. If you guys are new, my name is Michael. I'm teaching myself Python. I have a Bachelor of Science in Human Biology and a minor in Chemistry that I graduated back in 2021. I stream Python pretty much every night. I have a streak going where I'm learning and teaching myself Python. I've been learning for about 6 months now, and for about the past three, I've been learning pretty heavily and committing myself to learning really and dedicating myself. And I created this channel as a way to track that as like a video journal series, create a community of programmers, both new and old, to come together and grow and refine their skills, learn new skills, just have some companionship and network together as well. I have a Discord link below. The Discord is just a compilation of all my study resources from the PDFs on the top on my screen above me to all of my notes to the left side of my screen to all of my projects, everything that to do with my learning and the roadmap that I'm using currently, all the books like Fluent Python, Python Crash Course, everything that I'm using is all in there, PDF versions, ebook versions, my notes, practice problems, all that kind of stuff. So everything is in the Discord if you're a new programmer looking for a similar roadmap to maybe mine. And obviously, I will say just take everything with a grain of salt because I am learning and I'm learning this for the first time, obviously live in front of you guys. And with that, I will make mistakes. So I'm bound to make mistakes, and obviously, hopefully, we'll learn from those mistakes and have you guys help me along the way. So just take everything I say with a grain of salt. This is not like a teaching platform. This is a learning platform where we are learning together, you and me as peers, as equals together. That's my mindset with this. Yeah, thick books, right? We're getting to this one we're reading is 770. We're already on page 225. So, just little by little, day by day, if you just don't try to climb the mountain all in one day, if you get think about like a savings account. If you start saving, it seems like, oh, I'm never going to have enough money saved. But then like a year goes by and you look back and you got like 5-10 grand in that savings account. You're like, wow, like I didn't even think I had the ability to save up 1,000, let alone $100 every week. Little by little just slowly adds up, right? So you got to start somewhere, and little by little it's one day, not it's day one, not one day, right? That's kind of the quote I like to use, where people often say, oh, I'm going to do that one day, I'm going to take care of this one day, I'm going to learn Python one day. But instead of saying one day, how about you just flip those two words around and say, well, let's make today day one, right? And so just by flipping those two words around so simply is quite actually very powerful. um, you know just the swapping of two English words can have a completely different meaning and completely different butterfly effect on your life, right? So think about that. What I liked about React, Dom in React, you could see code changes in real time. There's a big learning curve. If anyone is interested in checking it out. Checking out what, Chase? What are you referencing for us to check out? For sure, I'd love to check out something, but not sure what you mean. Okay. Quote, why wait for tomorrow when it can be done today? Exactly. It's just a kind of like, in all honesty, it's kind of just like a laziness mentality of like, I'll just take care of it tomorrow. Well, if you think about if you just did the 10 minutes, the 15 minutes, the 30 minutes today, and then did another 30 minutes tomorrow, well, that's double the amount of learning that you did that we would have had done tomorrow. And then, triple amount the next day. So it's really like an exponential and compounding effect. Weird, I sent a message above that one. Yeah, I'm not sure which one you're referring to. It says front end is lame. My source is that I'm a front end. For sure, you're making a good call. If anyone's interested in checking it out. That was the... Okay, let's keep going here. So the sequence.push, is this the same as append? In Python, push and append are not equivalent. The append method used for adding elements to a list, where push is not a built-in Python list method. However, in some data structures like stacks, push is commonly used to add items. For a list, append is the correct method to add elements. If you're working with a stack, you might see push in other languages or libraries that implement a stack, but in Python, you would use append to mimic a stack's push operation. This is stack dot append e in Python. Quote, push is the I made a small little CLI tool for checking scores of NFL games from your terminal. I put a link to the repo in the messages, but maybe YouTube blocks links. I think it does block links in the chat. You for Chase, please, I would definitely like to use that. That'd be super cool to use, actually. Could you post that, like maybe a straight demonstration, or maybe like the markdown for the README in the project showcase of the Discord? That'd be great, and I'm sure some people would love to use that. I oftentimes I will be checking on the. If in case any of you guys don't know, I'm from the state of Oregon, and recently the Oregon Duck football team has been doing quite well, and so we're the number one team in the country, and we I didn't go to school at Oregon though. I wanted to, but it was just really expensive. But I am an Oregon Duck fan. I don't watch football too much, but I'll be checking the scores occasionally while I'm programming every once in a while. Does it just do NFL, or do you have a CFB there as well? If you're not the channel or mod, you can't post links. Okay. Yeah, I don't have any mods or anything. I'm pretty ignorant in when it comes to streaming and what it all does. I don't really know like what mods do, or like how to go down that process. I when I was growing up, it was streams were just kind of getting popular as I was graduating high school and getting into college. And so I was kind of like getting out of that whole portion of my life and that sector of entertainment when I was kind of getting more, growing up a little bit out of my childhood. So I wasn't super familiar with how streams work, as a lot of people that are younger than me do. Yo, what part of Oregon? Me too. I'm from literally like PDX, Portland. I was born in Portland, at a hospital in Portland. I'm a big Portland Trailblazer fan. Been a big Portland Trailblazer fan my whole life. uh, but I haven't been keeping up with them this past couple years ever since Damian Lillard got traded away. I was a real big Damian fan. Yeah, currently just NFL sports, but I'll be adding other sports soon. Awesome, that sounds great. CFBA is next on the list. Yeah, sweet. I would love to use that if you got CFB in there, because I mainly check the CFB scores. That's why I'm here. Awesome. Oh, sweet. Yeah, let's post that in the this project showcase in the Discord, and then I'm sure we have a lot of people that would love to use that. Leon goes to Portland State. No way. I I was gonna go there, but I didn't. I got accepted. They came to my high school and like did like live on the spot acceptance and stuff, and I got accepted to Portland State, and I think I did some dual credit in high school with Portland State, and that's really cool, Ian. That's small world. Oh my gosh, that's so awesome. I'm literally gonna be back in Oregon, Portland area over the Christmas break, so that's so cool. Dank, Dan Coroner, Dank and Dan. I appreciate it. Thanks so much. It's good to hear from you again. I so consistent. Keep it up. Yeah, well, right there with you. You're coming into the stream and showing support. So thank you so much. Yeah. Wow, that's so cool, Ian. I can't get over the fact that you go to Portland State. That's so cool. I had a lot of friends. I went to community college, Portland Community College, after I graduated high school for the first year and a half, 2 years. So I had a lot of friends actually that I would, visit at Portland State, and I stayed in some of the dorms up at University Point. Is it University Point on like on Clay Street and stuff, over by the exit to go east? I think it's University Point. Yeah, their chem classes are killing me, even though it's Gen Ed. Oh well, if you have any chemistry questions, I can definitely try my best to help you. Um, I uh, I graduated with a human biology degree and a minor in chemistry, and I work as a formulation chemist. And when I was in college, I was the undergraduate teaching fellow for general chemistry, and I was the lab instructor for the general chemistry course, where I was the only undergraduate that was a lab instructor. So I was working with all the other graduate students, and yeah, so I held a lot of the study sessions for the exams and all that stuff. Okay. I was pretty good. I'm not gonna toot my own horn. I was pretty dang good at chemistry. I was able to become the TA in the lab because it was pretty easy. It was pretty natural for me. But looking back, I wish I kind of would have done CS looking back, but it's okay. Okay. Additionally, let us define the following accessor methods for convenience. Sequence top returns a reference to the top element of the stack without removing it. An error occurs if the stack is empty. Okay, so we can get so 3 would be sequence dot top returns a reference to the top element of the stack S without removing it from the stack. An error occurs if the stack is empty. S is empty. S dot is empty. So is empty, return true if stack S does not contain any elements. 5 length S. Returns the number of elements in stack S. In Python, we implement this with the special dunder length method. In Markdown, does 2 underscores cause some sort of bold effect? So I need to keep a quote here. Is there like an escape operator for not allowing the dunders to happen in Markdown? Or will I have to just do Python dunder length like this? Like so. Like that. So if I go shift command V, we get the length method. Okay. All right, we got some chats here. Avinash says, "What exactly do you do for your job, by the way? Formulation chemist sounds interesting." Hall Monitor says, "Now I understand how you have such a strong study habit." Yeah, I for a large majority of my life, you guys, it's been heavily focused around school and education. I have been very dedicated and pushing myself in terms of extracurricular classes, doing maintaining and that knowledge and further solidifying it. So that's a lot of my hobby. Take that with what you will. Is I don't have a lot of hobbies besides continuing my learning and everything. So that is how I am able to dedicate that time to this. Is that this is a hobby of mine. So if you guys have other hobbies, then obviously you have to fill your time with those, and it takes away your ability to study and things like that. So it's just every person is different, right? So it's obviously it can hurt to compare. Yeah, so Avinash, for my job, just based to without getting too into the mud and details of it, I'm a formulation chemist, and so what that entails is I have to follow a lot of regulations and guidelines instilled by like the FDA and regarding like documentation and just general lab practices. So because I'm involved in my company is a biotech company for um, you know uh, sorry, I'm kind of getting off topic here. I'll just go back and say that the main objective of my job is I formulate and create products which are biological products in the forms of biological controls. So, whenever you're like a patient experiencing some sort of illness or ailment, maybe you're, something along those lines, and you go to a physician or a clinic or something along, and the physician in the clinic, they will take samples from the patient to do immunoassay runs and testing on those patients. So they will sample blood or urine or plasma, serum, some type of biological element from the patient, and take that, dilute it down to some sort of consistency, and run some tests on it to obviously you know diagnose this patient. um, what exactly provides that, or the details to the physician or clinic that that information that they're providing is accurate, right? Their machine may be calibrated as so, but who's to say that that calibration is valid and remains valid for that extended period of time within its calibration period? So that's where in the scientific method is you apply the values of controls in terms of any sort of testing, right? So you have a control element, which is what I make. So my products, I make them at very small scale at first. I do some testing to make sure I have everything in the right range, and everything is looking good on a very small scale. But then I will expand that product up 1,000 times bigger, or 400 times bigger, or whatever the scale factor is. Upwards of 500 to maybe 4,000 liters of fluid, within a giant, stainless steel tank, and filtration apparatuses, and steaming and cold switches to, fill the jacket of the tank, and it's very complex. This big lab I work in, and I've had to do a lot of training over the past 3 years. But so I make these controls then that are just mimic, or show the validity of these machines for these various diseases and diagnostics. So when the physician will take the patient sample and compare it and run it against my control value, my solution is then bottled down into vials from way large thousands of liters down into small milliliter vials that are then sold and marketed off to companies and hospitals and biotech physicians and clinics and all that kind of anyone who really would be willing to pay for it, right? Uh, so these companies will then just run these values of my control, because inside of the product it has like, okay, if you're testing for sodium, this is the range of sodium that you're supposed to be getting back to ensure that you're testing at an accurate range or a level. And now that's just for a small example. These things would be more like enzymatic things within the body, or specific, cellular levels and things like that. Not just sodium for a basic point, but more like in depth, maybe like certain protein levels, like lipoprotein A, or LPB, or APOA, APOB, things like that. These different, you know, proteins or enzymatics, or enzymes and things like that on a biological cellular level. So all in all, my job is to just provide a control to provide the peace of mind when giving the diagnostics to patients or various other research programs, so that they know that their testing was within certain bounds, because the FDA does regulate that you have to have these valid controls provided in the testing documentation when you're like doing these clinical research things, or formalizing new patents or things like that. Is you have to provide these FDA controls, which are verified with the FDA through various companies, to ensure that your data is accurate and repeatable. Sorry for a lack of big explanation. Sorry, that was a ramble. Leon says, "Yeah, I'm doing CS right now. The program here at Portland State is surprisingly rigorous, with nice opportunities for jobs/networks, more than I thought of at least." Yeah, Leon, I'm that's where I'm from, Portland area. I was grew up and born and raised there. I would definitely try to network with Intel. You have a huge Intel campus over in Hillsboro, Beaverton area. I would definitely try to market and we get into software engineering for maybe like Nike, like a lot of those. They are retail companies and like consumer based companies, but they do have online and software based platforms. But the Portland metro area is heavily concentrated with Nike headquarters, Reebok, Adidas, Intel. I think up in Washington, slightly over the border, you have Taiwan Semiconductor. So you have a lot of opportunities to, there are a lot of very centralized companies in that area that you can definitely find work for. Easy, be a biochemical engineer. Yeah, I was definitely. I need to. I don't know what those types of jobs entail, right? I just don't have the experience really. Um, I don't know. Yeah, I have to look into all those things. Chat, I'm not gonna lie, I need C++. My brain is scrambled. Just posted a project on Discord. Check it out. Just did football is so cool. Have you tried it out? Just looked at it. All right, I'll check it out, Chase. Thanks so much for posting that. I'll be adding some more sports and adding functionality. I'd love to be able to go into an interactive mode and swap between weeks and seasons. I'm just trying to think of project ideas. Awesome. Or have an auto refresh mode where it stays active and updates every 10 seconds. It was designed at Google to be kind of modern successor to C++. Oh, awesome. Yeah, super big community and a lot of hype around it. C++ is a fantastic language, don't get me wrong. Software performance is always never the fault of the language you pick. Sounds of Avinash says, sounds super interesting. Thanks for the explanation. Oh, yeah, no worries. Thanks for the question. I appreciate you. Yeah, scripts. I think if you're trying to, think of some elaborate project to begin with, you might be setting yourself up for defeat. So maybe just try to implement some small singular feature and then expand that feature to two features and then three and then four and then five. Next thing you know, you have a five features conglomerated to, call a whole project. So just think of one feature that you can write right now, right? That'd be cool. All right, let's keep going here, you guys. By convention, we assume that a newly created stack is empty and there is no a prior bound on the capacity of the stack, priori bound on the stack. Elements added to the stack can have an arbitrary type. Okay, the following table shows a series of stack operations and their effects on the initially empty stack of the integers. So push, stack 5 will add 5 to the top of the stack. 3 will then add 3. Length will take as 2. Pop will remove 3. Is empty is false. Pop will take 5 off. Is empty becomes true. Pop gives an error because you're empty. Push 7, add 7. Push 9 will add 9. Top will reference 9. Push 4 will add 4. Length will give us 3. Pop will give us the 4. Push 6 will add 6. Push 8 will append 8. And pop will remove 8. Cool. 6.12, a simple array-based stack implementation. We can implement a stack quite easily by storing it its elements in a Python list. The list class already supports adding an element to the end of the with the append method and removing the last element with the pop method, so it's natural to align the top of the stack with the end of the list as shown in figure 6.2. Implementing a stack with Python's list. Okay. Although a programmer could directly use the list class in place of a formal stack class, lists also include behaviors, adding and removing elements from arbitrary positions that would break the abstraction of the stack ADT represents. Also, the terminology used in the list class does not precisely align with the traditional nomenclature for the stack ADT. In particular, the distinction between append and push. Yeah. Sorry, guys. Ah. So right, the push and append methods aren't exactly the same. Instead, we demonstrate how to use a list for internal storage while providing a public interface consistent with a stack. The adapter design pattern applies to any context where we effectively want to modify an existing class so that its methods match those of a related but different class or interface. One general way to apply the adapter pattern is to define a new class in such a way that it contains an instance of the existing class as a hidden field, and then to implement each method of the new class using methods of this hidden instance variable. By applying the adapter pattern in this way, we have created a new class that performs some of the same functions as an existing class, but repackaged in a more convenient way. In the context of the stack ADT, we can adapt Python's list class using the correspondence shown in table 6.1. So we can use a list, but we need to preface that these are the only functions that we can use with the list if we're going to treat it as a stack. Right. That's what it's saying. We can have an adapter pattern, which pretty much is like a key to signify that these are the so top would be in Python would be s at index -1. But that removes no, it doesn't remove that value, it just accesses that value reference. Sequence of -1, yeah. In Python. Implementing a stack using a Python list. So is empty would be length of s is equal to 0 in Python. We got some chats here. Often just browse Hacker News and see what other people are working on. Usually gives me some information. I mean, my friends see me as a gray hat. Well, my brain hurts. Question: what is a good resource to learn how to set up a Python project? Virtual environments, pip directory, setting up a project is a lesson on its own. Any intro to Python book probably works. Gotcha. I took a Codecademy Python 3 beginner course and I finished it, but it didn't teach setup. One way that I at least set up now take this with a grain of salt, like I say, is I only set up a few projects, but I watched this one guy, he recreated Terraria in Python. He never actually finished the game, he just kind of created some similar features and did it that way. And I kind of liked his flow for the project creation is he kind of created like a global variables file, and then he you know it's really hard. I mean, obviously you could just set up a virtual environment right away, set it up link it with Git, link it to a GitHub repo online, and then you need the git ignore, obviously that's created with the Git. So you want to ignore your virtual environment. but that's probably just what you need to get started, and then just add things into the git ignore as you add, files or things along those lines, right? In the back of Python crash course, I would definitely take a look. Who was it? That one fit squad. The back of Python crash course in part two. So part one in Python crash course is all about the actual learning of methods, functions, all those ins and outs of Python. But part two will actually tell you and walk you through how to set up projects and do projects. So go into the Discord linked below and pull the PDF of the Python crash course and reference part two, and maybe that could help you give you some insight on how they do it at least. Virtual environment or Conda is the way to go in my opinion. The setup always depends on the framework you're trying to use, the Django, Flask API. Michael, you should totally on your next live do a bit of C++. LOL. Interesting. Michael may be informed than I am on beginner resources. Yeah. So definitely Python crash course at the back, part two. Or what I did is I don't know the link, but I watched this guy I just random one night for an hour. I was before bed. I was about to fall asleep. I threw on like a making Terraria in Python from scratch, like a like 5-part series or something, and he just set it up like how I kind of mimicked his flow here for my small business manager, where I have a globals.py where I import things in from like constant variables, because Python, doesn't have the constant variable notation other than just capital letters for the variable declaration. I have the git ignore from the that I created when I had the git that was created. Um, yeah, so I don't think there's any just one way to do it. Obviously, just add files and organize it into any way that you really see fit, and as long as it can work, I guess that's what matters. I think. Um, was doing it with the Django. I was able to AI my way through some of it before, but I got stuck and I wanted a bit of understanding for it. Yeah, actually, exactly. One Fit Squad in the back of Python Crash Course in part two, they have a a project that actually uses an example of the Django. So this would be a perfect place to go if you're using that. I actually never did that myself. I started doing my own projects after part one, but definitely take a look at that. Um, I just got an idea of the game you just mentioned. Mike, I feel like you'd find C or C++ very rewarding. It builds greater intuition of how things truly work under the hood. Yeah, I might need, it definitely sounds like I need to maybe give those a try in learning. What is the difference between C or C++ or like C sharp? Is there any like major differences in those? And if I were to maybe start taking a peek under the hood about what that language looked like and relating it back to my whole mantra with this is I'm not trying to be like the stereotypical beginner software engineer where they try to just accumulate you know programming languages like Pokemon gym badges, right? Where once I have all 8, then I think I can go take on the Elite Four and take on Fang, right? But I really don't. I think that trend is really really dated and really really faded, and so um, I think that there might be a lot more value for beginners to dedicate themselves solely to one entire language mastery before expanding outward. But if C sharp or C++ or C will help me to then further solidify my Python knowledge, then I'm all for that as well, because I'm sure that they used similar frameworks, because Python is obviously based off of a C compiler in some form or something like that. So yeah, let me know about that. All right, let's continue on here. Lots of chats, guys. You guys are great. All right. C is the language that most of the world runs on. It was invented by Bell Labs in the 70s as isn't perfect, but it's the widely adopted as the first truly high-level language. C++ builds on top of C for object-oriented programming pretty much. So if I was to take a peek under the hood at one of these languages to further solidify my Python knowledge, what would you guys recommend regarding those two? And is there any like resources that I could that you guys would like to pair similar to maybe Python Crash Course or something? Um, C Sharp is totally different and is way more similar to Java. Okay, I didn't know that. Like I said, I had never even really seen any lines from those languages. But as long as I can still relate this back to Python and carry this knowledge forward together, that's kind of what I'm mainly focused on in Kiyun. One Fit Squad said, I just joined, I believe. Is it the AI technology server or is it under Python new to Discord? It's the Python crash course is under the Python in the Discord. So I'll take the Discord over here, drag it over to my screen. If you go over to Python channel and in Python crash course book, you can see I have the PDF here. I provide my notes that I took while I read it live, and then I also have just a link to the playlist where I'm doing the solutions to the try it yourself problems in the book. I'm currently on making these ongoing. We use the implementing a stack using a Python list. We use the adapter design pattern to define an array stack class that uses an underlying Python list for storage. We choose the name array stack to emphasize that the underlying storage is inherently array based. One question that remains is what our code should do if the user calls pop or top when the stack is empty. Our ADT suggests that an error occurs, but when we must decide what type of error. When pop is called on an empty Python list, it formally raises an index error, as lists are index-based sequences. That choice does not seem appropriate for a stack since there is no assumption of indices. Instead, we can define a new exception class that is more appropriate. Code fragment 6.1 defines such an empty class as trivial subclass of Python exception class. So class empty exception, error attempting to access an element for an empty container. The formal definition of our array stack class is as given in code fragment 6.2, the constructor establishes the member self._data as initially empty Python list for internal storage. The rest of the public stack behaviors are implemented using the corresponding adaptation that was outlined in table 6.1. Example usage. Below, we present an example of our usage of the array stack class, mirroring the operations at the beginning of the example 6.3 on page 230. So what they did was they created an array stack class, which because Python doesn't exactly have a stack ability to create stacks, we will use a Python list to mimic that of the stack, but we need to apply to it various methods that would be consistent with that of a stack, because lists can be indexed into. So with this array stack, it takes in the last first out stack implemented in Python's list as an underlying storage. So when we initialize, we create a list, right? Has the data in it. When we have a length of the data, we have an empty. If it is empty, we return 0, or return the length equal to 0 is true. A push just does the append, right? We have the append associated with push. A top just accesses the negative first data point, and the pop element will just do the data.pop for this. So as you can see is with these methods implemented for the array stack, we are able to just mimic an array using a Python list, or sorry, a stack using a Python list. But the key difference though is with lists, we cannot directly just use a list. We could intuitively use a list and know that it has to have the same properties of a stack, but lists and stacks are different where stacks cannot be indexed into and those values cannot be removed. The only index value we can access of the stack is the topmost value of the stack, or the negative first index value. Chase from Space says, Python and Python's interpreter is written in C. Try looking up some videos, blogs, or papers on how to build a language like Python with something like C. That might help give more intuition while relating it back to Python. Just talking arrays as an example, there are so much more simplified in Python than in C, where you have to manage your own memory manually. Exactly. Yeah, that's what was being talked about. All right, I'm gonna start a C++ project. Great. It sounds great, script. SS Low says, I actually used an embedded Python interpreter in my C++ project. Awesome, that sounds great. Turned out that it was simpler to use PyInstaller to turn a Py script into an exe. Oh, got you. So SS Low, when you're talking about turning a Py script into an executable, is that like making a Py script like a desktop application? Like like as if you wrote, let's say for lack of a better example, like if you wrote Photoshop in Python and it was a .py file, are you converting it to an exe to get like a to load up Photoshop on the desktop? Or I never really understood how that worked. Chase from Space says, like several people are pointing out, C and C++ are not memory safe. It is easy to write program with memory leaks comprising security, reliability, and performance. Chase from Space said, that being said, because it doesn't have things like garbage collectors, technically you can write super sleep slash lightweight programs which are super efficient. For example, perfect C code is technically better than pure Go or Rust code in terms of performance. In practice, though, that is not the case. Interesting. Well, it really really sounds like something I need to take a look at. Maybe we should set some time on the stream in the future to take a look at that. Do you guys have any resources you guys could provide, similar to Fluent Python, Python Crash Course, or something along those lines that I could take a peek at? And would be what did you guys use? You guys probably learned it in school from lecture and stuff. Okay, cool. Analyzing the array-based stack. Table 6.2 shows the running times for our array stack methods. The analysis directly mirrors the analysis of the list class given in section 5.3. The implementations for top is empty and length use constant time in the worst case. The O of 1 time for push and pop or amortize bounds. A typical call is either of these methods uses constant time, but they're associated occasionally an O of n worst case, where n is the current number of elements in the stack, when an operation causes the list to resize its internal array. The space usage for a stack is O of n. Okay, so we can say then that we need to say here stack running times the uh, dot top dot is empty and dot length use constant or length function, not length, dot length, use constant time in the worst case. Big O of 1. Push and pop are amortized. Dot push dot pop are amortized. Because of the dynamic array sizing underneath. Amortized big O of n worst for time. of the dynamic array sizing underneath. Cool. Performance of our array. The space usage for a stack is O1. The space usage for a stack is O of n. Okay. Performance of our array-based stack implementation. The bounds for push and pop are amortized due to the similar bounds of the list class. Okay, so they push are amortized O of 1 time because the dynamic, which takes O of n. Because of the possible dynamic array resizing underneath. Cool. Yeah, SSLO says, turning a PyScript into an exe is very helpful if you intend on distributing your program to others, especially when the users aren't computer literate. Chase from Space, frankly, I didn't learn any programming languages during my bachelor's in computer science. Chase from Space, as the saying goes, computer science is as much about learning computers as astronomy is about telescopes. Ah, interesting. That's a good analogy. Same holds true for any specific language or framework. At least in my experience, a computer science degree is really just a specialized mathematics degree. Chase from Space, also in terms of resources, Michael, in Golang, the Golang website has an open source book called Effective Go on their website, which is good, and that's how I started at least. From a textbook standpoint, A Tour of C++ is a great textbook. Cool. Do you guys mind if you guys have links, maybe throw them in the Discord? That'd be great, and I can definitely check those out. Is Golang, what's the difference between C++ and Golang? And would it be more beneficial to take a stab at C++ or C? I don't know. C++? What was the difference again? C++ allowed for object-oriented programming. Superset is designed to be C with classes. Python is like making pre-cooked meals, while C is more making it yourself, especially learning pointers in C. Yeah. Well, that's definitely sounds like something we need to get some familiarity with. C++ is C with classes, so it'd be probably just to do C++ then, and just say, yeah, sorry, if you're gonna go the full intuition route, I just go with pure C. Go with C. Okay. All right, with just regular C. So I'll do some research on some forums looking up some good C books, and maybe we could give that a shot, once we get through some of this other material. Do you guys feel that knowing a language of C versus or C plus or C or C++ versus Python, do you feel that it allows you to do more? Like you often said that it's not really dependent on the language. It's just can you be able to know all about the language to actually be able to write what you want to write? But can you do more with a raw base level language like C and C++ than you could with Python in the terms of like development point of view? I'm not sure if that makes any sense. I'd go with C++. The standard library makes it feel almost like a higher level language than it is. I might screenshot a preview of the script. Well, maybe we can just try read a book about both or something. Avoiding amortization by reserving capacity. In some contexts, there may be additional knowledge that suggests a maximum size that a stack will reach. Our implementation of array stack from code fragment 6.2 begins with an empty list and expands as needed. In the analysis of lists from section 5.4.1, we emphasize that there is a more efficient in practice to construct a list with initial length n than it is to start with an empty list and append n items, even in both approaches run in O of n time. As an alternate model for a stack, we might wish for the constructor to accept a parameter specifying the maximum capacity of a stack and to initialize the data member to a list that is that length. Implementing such a model requires significant changes to relative to the code fragment 6.2. The size of the stack would no longer be synonymous with the current length of the list, and pushes the pop of the stack would not require changing the length of the list. Instead, we suggest maintaining a separate integer as an instance variable that denotes the current number of elements in the stack. Details of such implementations are left as exercise C 6.17. Okay, so basically what that talked about is if we wanted to avoid the entire aspect of amortizing a stack via the calls to push and pop, right? We know that the arrays are dynamically being increased and decreased as we push and pop elements off. We could end up filling the array and needing to call a dynamic array to be made in the system's memory on the back end. Now we can completely avoid that, right? We can completely avoid that by just initializing our stack to have a predetermined capacity maximum. So if we initialize the stack with a parameter or an attribute as like a 10 as our maximum capacity, well, we know that once we reach 10 elements in the stack, we can no longer append any more elements and we can only pop from that point. And so we wouldn't need to actually create an ability to dynamically create. And so all of our, our calls would then run in constant time perfectly. You'll get a lot of different answers to that question. I think it's really hard to say. I just feel like in general with comp sci, there's just a big learning curve in general. Chase from Space also says, I would just start learning in every direction and eventually you'll close the loop somewhat. Chase from Space also says, do what you find is fun and stop asking questions no matter how, and don't stop asking, he said stop asking questions. Do what you think is fun and just stop asking us questions. Come on, man. I read that completely wrong. Do what you like is fun and don't stop asking questions no matter how confused you get. It depends on what kind of development you're doing. You can almost do everything, but it can become a real pain really quickly. What C++ did for me was help me learn DSA really efficiently, mainly implementing data structures while not using the standard library where they're already implemented for you. Because of course you always will learn better by doing. All good advice. Great, yeah. I'd say a strongly typed language helps you think more clearly about the design of your function, classes, etc. But you know exactly what data to expect. Because of what you're doing is crazy, I could never learn straight from the textbook, but that's just me. That's why I love type annotations in Python. Oh, gotcha. Yeah, some people, have trouble learning from the textbook. I used to not read textbooks at all, but I found that there's a lot of value in just being able to read these words over and over and over again until you get it. The information is there, right? It's all there in these words. Is you just got to make it out, right? You just got to pick it out of the words. So, reversing data using a stack. As a consequence to the last in, first out protocol, a stack can be used as a general tool to reverse a data sequence. For example, if the values 1, 2, and 3 are pushed onto a stack in that order, they will be popped from the stack in 3, 2, 1 order. This idea can be applied in a variety of settings. For example, we might wish to print a lines of a file in reverse order in order to display a dataset in decreasing order rather than increasing order. This can be accomplished by reading each line and pushing it onto a stack and then reading the lines in order when they are popped. A implementation of such a process is given in code fragment 6.3. So we have a function what we call reverse file, where we call some sequence for our stack array class. We have original, which would be open some file name using open function. For every line in the original file, right, we want to push the line. And then original.close. Now we overwrite the contents. We open in write mode. While it's not empty, we pop each line out. Chase from Space says, if you really want to understand languages, building a language is a really fun project. I was planning on reading the build your own compiler slash interpreter in Go. Building things like parsers and interpreters really closed the loop for me somewhat. I haven't read it yet, but it sounds like a cool project. Message me on Discord and I'd love to work with you on it if you're interested. That sounds really cool. Maybe we should try to take a stab, like after we finish the task tracker project. What about this, guys? After we finish the small business manager project, not the task tracker, the small business manager, what if we, because at that point we'll probably have finished DSA in Python, and we probably have finished, at that point we'll probably have finished this book. So we'll have a really good understanding of Python, and then we can try to do the fluent Python on and off part time. But at that point, let's go ahead and shift focus on maybe picking up some C++, or sorry, some C, and um, and then maybe we can you start making a project for making a language on the channel. We'll try that. That'd be a good idea. What do you think about that? We'll make Michael's language. Okay. One technical detail worth noticing is that we intentionally stripped trailing new lines from the lines that are read, and then reinsert new lines after each line when writing the resulting file. Our reason for doing this is to handle a special case in which the original file does not have a trailing new line for the final line. If we exactly echoed the lines read from the file in reverse order, the original last line would be followed, without new line, by the original second to last line. In our implementation, we ensure that there will be a separating new line in the result. The idea is to use a stack to reverse a dataset can be applied to other types of sequences. For example, exercise R6.5 explores the use of a stack to provide yet another solution for reversing the contents of a Python list. A recursive solution for this goal was discussed in section 4.4.1. A more challenging task is to reverse the order in which elements are stored within a stack. If we want to move them from one stack to another, they would be reversed, but if they were then replaced them into the original stack, they would be reversed again. So right, if we took last in first out and pushed them into a stack, they'd be reversed order. But then if we took those out and put them back in the original stack, they would just go back into the original order that they came in, thereby reverting to the original order. Exercise C 6.18 explores a solution for this task. Interesting. So what could we do if you had a stack and you took items off and put them into another stack, so the top becomes the first item in this new stack. So you have stack here with some elements on it. You take an element off and you put it into the starting element of this new stack. So boom, it's here, right? Boom, 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 boom. If you start taking all those off, well, they'll just unfold back into the order of the original stack. So you'd have to take an element off. You have to save it in the stack, take off another element, save that in a separate stack. You'd have a stack for every element and then compile the stacks together. Because you can only take things one at a time. So you'd have to take that reference and save it elsewhere rather than in a stack, another stack. Or just leave it in a stack with a size of 1 and you'd have n stacks. What do you guys think? How would we go about solving this if you wanted to reverse the order of the stack, right? If you were to just unfold the stack and then refold it back, well, the order would stay the same. So you'd have to you have to pop each element off and save it in an external environment and then reload those all back in that order, like that recursive order. Yeah, feel free to post screenshots of any of code and stuff in like the general chat or in the off-topic chat or whatever, if it doesn't have a specific place in the Discord. Thanks, Chase, for coming in and being so much. What it what if you just have this three stacks? So what if we had three stacks? So we have stack 1, stack 2, stack 3. So this has elements on it, right? So this has 1, 2, 3, right? So 3 would have to go here. 2 would go here. Ah, okay, so you would alternate the stacks that you remove. So 2 would go here, and then 1 would go here. So then you unfold from here like that. Ah, okay, you alternate from the two stacks. So you use two stacks as your unfolding, and you alternate your unfolds. Ah, we're getting it, guys. We're getting it. Woo! Right? So that means you'd have odd number stacks here, even number stacks here, and you would unfold even odd, even odd, even odd, even odd. Interesting. Is that how you would do it, Chase? All right, where are we at? We're almost to 6.2. By the way, if you guys are new here, for those that don't know, I'll just quickly say my name's Michael. I've been streaming every day for the past like 2-3 weeks. I've been trying to getting a streak going here. I've been learning and teaching myself Python pretty religiously, and I'm very driven in learning this and wanting to challenge myself to do better and improve. I'm very I'm holding myself accountable, and I use this stream as another resource to hold myself accountable with you guys and the friends and colleagues I'm making on here. I graduated back in 2021 with a degree in human biology and a Bachelor of Science in human biology and a minor in chemistry. And I work as a formulation chemist for a biotech company for the past 3 years. Yeah, so if this is something that you're interested in or in a similar situation to mine, or just in school or wanting to just learn programming in general, feel free to follow along to the channel. This is a great place to be. I learn new concepts every single day. My knowledge is growing every day, and it's been a real treat to have you guys follow me along this process and learn along as well. So the channel's been growing quite rapidly. We're almost to 600 subscribers here coming up. So it's just really unbelievable that we're really growing like this. Okay. And if you're watching the stream, please, if you could, it'd be so nice if you could just maybe throw it a little thumbs up. I don't really ask for those much, but they do, I guess, help other people like yourselves and other, programmers find the channel in their feeds and then the algorithm for YouTube itself. So if we can just try to get as many people here together and it just create a big community of it just the bigger the better, in my opinion. We can just have the more ideas, the more resources, and yeah, different point of views. So if you could just throw it on maybe a like, yeah. I got the hiccups here. Okay, I think I'm going to kind of wrap it up for today. We got a lot of interesting stuff done for stacks here. We worked on 4 of the chapter 5 problems on dynamic arrays, and then we're getting into stacks. Stacks seem pretty easy and self-explanatory for the most part for right now. It's definitely probably the least confusing thing we've learned about so far. This stacks just seem very intuitive and self-explanatory for how they operate when compared to what we've learned about so far. But I wanted to quickly pull up the Small Business Manager and just kind of demo what we worked on yesterday. So for those that don't know, in the Small Business Manager yesterday, which is the project that we're working on after we do our learning in DSA and other various learnings in programming, we just implement the knowledge into actual projects to practice. We successfully added a feature where if we find an item via item number, we are prompted with a display for that item here. So the item actually displays for us, and then if we go ahead and update parameters such as the name, so new name, it gets updated live in this while loop, right? So if I update size from medium to extra, extra large, right, that gets updated right there, live right in front of us. So, and then if we press 6 and then save the program, right, if we save and pull up our file, well, that item was saved all along for those updates. So we were able to add in those live updates and that refreshing in our last episode or our last stream. Let's get the lava lamp shaking up here. Let's get some lava going. Woo! Look at that. Nice. Look at that. Super cool. I don't know if you can really see that on focus or not. Okay. So now, yeah, so we've been able to, properly detect that when, items are being changed and then they're being updated live accordingly. So we actually don't have a function for setting this active status yet. So I think before we go, we just need to at least add in one feature to the Small Business Manager today. One feature a day keeps the doctor away. Um, we'll just add in the ability to override this active status here. So we need a function in our function for actually running the edit talking about the lava lamps. You should definitely check this out. Tanmay, you'll have to throw me a link in the Discord. I don't think YouTube allows external URLs in the chat, unfortunately. But I would love to check out a lava lamp link. I want to get like a big, like a foot one, or maybe even like a 2-foot one for like the stream background. That'd be so cool. And then what if we did this? What if we made a randomizer that used some sort of camera to track the lava lamp flow to create random, right? Because we know that the random module in Python uses some sort of mathematical approach to predict the next element or the next random element. And so it's not truly random. So what if we used flow patterns that were detected using like, some sort of camera or whatever to like create some sort of randomization. He said, quote, "That's exactly what this link's about. It helps keeping encryption secure." Yeah, I think I know what you're talking about. There's a bank or some sort of maybe like crypto agency or something that they have a wall of like bubbles or lava lamps or something, and they have a program that watches these orbs as they float through this liquid, and that's what creates their encryption or something along those lines. Is that what you're referring to, Tanmay? That would be so cool. We should totally try to write a lava lamp encryption program or something, right? That I don't even know where to start with that, but we start from zero and work our way up. Is that something that sounds cool? Yeah, it's Cloudflare. Okay, what do they use exactly? Do they use lava lamps or is it like a pool? I saw the video too. Yeah. Awesome. That sounds really cool. Yeah, I don't even know where we would start. Lava lamps. Okay. Let's definitely that'd be cool. Let's try to do that. Like recreate that lava lamp encryption. That'd be sweet. That sounds like a really great project idea. Okay, so um We also set up the view all items, I think, last time. So if I go back to inventory, I do view, I do all. Yeah, we set this up last time too. We need to clean this up though, and we need to add in these other filters. Because if we press Q here and go um, view all for all, view all, run view goods, view items, all inventory. So when we view all items, we print them all, but then we're looping using the create menu, and we're not staying on this loop. So by pressing Q here, if I go main menu, exit, yes. If I run inventory, view, all items, the program just ends. Right. So I go view, inventory, view, inventory. If I go for cell items, that ends. Inventory, view, and yeah, it ends, okay. So it ends, there's no callback to the previous function here. So we need to ask for user input here and say input, we'll say what if we say this actually? Down here in the view items, we'll say print each item, and then we'll say, after this, we'll say print quote press. Where's my press Q anywhere in here? What do I have that anywhere here? Press Q to go back. Where would I have that here? Here? Here. Press Q to go back to inventory menu. Like this. Copy. Okay, and then I'll take this and put it in my view function down here. And we'll say print this. We're going to get user input is equal to this. So in the view here, we need to say while true, we want to display the items. We want to ask for a user input at this point to detect when we want to quit out of this view. We want to say I'm going to go like this. Actually, I'm going to say try and get user input, right? No, we won't say try actually. Let's just say we'll get user input. After this for loop, we're going to say if user input is equal to quote Q, we want to go ahead and call run inventory menu. we want to run inventory. Well, does that clear? Run inventory does do a clear at the top of the terminal page. So we need to all active items in inventory are being displayed here. Right. I want to hashtag tab in on each item number value in the for loop, and then we're going to get user input. If they press Q, we're going to run inventory. So while true, we need to clear terminal here, like that. Run inventory, else. If they don't press Q, we're going to continue the loop in display. Prompt, we're going to say, we continue so what is the order? It's you clear, print, continue. Clear, print, continue. Clear, print, continue. Okay, so if we clear, print, continue is the order. So if we press Q here, if you don't press Q here, we clear the terminal, we print the error that's decided, press Q to go back to inventory, right? That'll give us the error, and then we continue the loop. So now if I go ahead and run this function, inventory, view inventory. Okay, this gives us the error right away. So on main menu, inventory, view inventory. Okay, so the view inventory, the clear terminal is not happening here. So so we go view inventory from the inventory manager menu. This does the please select filter. Please select. So let's go to the run view inventory function. Please select a view filter. And then on this function, on the run inventory, we need to clear. On the create menu, are we doing any clearing? On the create menu, we only clear on the errors. And then on the errors, we only clear. So if I run here, inventory, view, right? Do we need to clear here? If I press 1 for all items, we get the clear and we get the loop. What's going on here? Come on. Yes, inventory, view. Please select the filter. Please select the view filter. All items. That gives us that. So we're stuck in infinite loop now in our view. So while true, we're going to print Control Z. Here we go. So why are we getting a extended list here? So if it's all while true, we clear, print all active items. After we print them all, we ask for a user input. If the user input is equal to Q, else we clear and go back. And continue. I don't get why is this looping then? Why is this broken? Why are we getting a infinite loop here? I'm not pressing anything. I'm asking for input here. Why are we getting an infinite loop here? All active items in inventory. Oh, here we go. We're not actually calling an input function. There we go. Inventory, view, all items. There we go. Alright, we weren't actually calling an input function on this menu prompt here. So now, if we enter in ABC, we get that. Error, please, and then clear terminal prints this and clears again here. So I don't want to clear here. Run there, here, inventory, view, all items. That does that. So on the view, right here, we want to do a clear terminal and then run this. And then here we'll do a clear terminal as well. And then here we'll do a clear terminal as well. So now if we run this and do one, inventory, view inventory, all items, boom, just like that. If we press ABC, if we enter ABC, we get this error message up top, and now we get that reprompt. And then we can press Q at any time to quit. So we want to input, press Q at any time to go back to inventory menu. Let's go \n here to make that consistent. Find item by doesn't do it. Set item number doesn't do it. So this will actually, we don't want it there. Error, input, user input, invalid. Press Q to go back to inventory, continue. So now we should get a new line prompt there. So we go one, inventory, view, all items, boom, just like that. All items in inventory, we get the input on the next line, and then if we press 1 here, we get error, input 1, invalid, press Q to go back to menu. Input quote invalid. Please press Q to go back to inventory menu. And then we will also provide a new line statement here as well. So if we run this, yes, inventory, view, all items, there it is. If we press 1 here, we get the error. If we press ABC, we get the ABC. F is invalid. All we need is Q to go back to main menu. Cool. Woo! I finished my project. I posted half the portion of it on off topic. Awesome, that's great. I'll take a peek at that. I'm also going to attempt to learn HTML tomorrow. Sweet. That sounds like a great idea. You should we'll come back in the stream and we'll we'll hold each other accountable while we learn. Awesome. Great JavaScript. Super proud of that. Okay, so now before I just want to add in one last feature before we call it for today. I want to add in the redefining of the active status. So in the edit item, so this is the view inventory. We don't want to access that. In the edit item function, we want if the active status, we have set active status function here. So we have to come here, I'm going to do def set active status function. Right? So in active status, are we taking in an item? So in my other ones, we are not taking in an item. We are calling edit item on the item itself. So we get back into this menu. So set active status needs to be, so we'll say we need to say we will create menu here. We'll say user input is equal to create menu function, where our prompt will say set active status. Set item active status. And then our options, our list of options is going to be true, false. Right, so our create menu doesn't require strings, right? Create menu takes in options, list, tuple, or set. So this will be a tuple. Or it'll be a set, I mean, sorry. A set. We'll try to do the user, okay. So we have a set of true or false, right? Or this, in this case it's a tuple, but it's whatever, we'll just keep it as a list. True or false, if user input, we'll say match case user input one is equal to if one, we're going to return true. Case quote 2, we're going to return false. Right? So if user input, we're going to detect true or false. We're going to create a menu. We're going to match the case and return these cases. I'll just continue. So, right, if I do set quantity, does the same thing while true. We need to give these are options. That's why I use the create menu here rather than a single while loop for just a single menu item. So set date created, create menu, run else. Okay, cool. So now our set active status function for those items are working appropriately. So in edit item, we will call set active status. This will return either a true or false as new active status, and we'll override it and set it as that. So if we run this program now, yes, inventory, find edit. Let's see, the last item in our list is 10. So item number 10, right? That brings up all the attributes associated with item number 10. We can press 5 to set active status. Bool has no... okay, so we need to set it to quote true, not actual true. So this would be quote true, quote false. Like so. So now if you run yes, inventory, find edit, item number 10, if we set active status, okay, that gets that. So create menu doesn't automatically title case. It doesn't. No, so it doesn't do so. So we need to have the set active status function call a clear. So here we'll say this is going to be set item active status. Call this yes, inventory, find edit item number 10, set active status. We'll set it to false. Boom. Cool. Yes, that did it. So if we set active status back to true, cool. If we set it to, oh, this is size XL. We set active status back to true, stays true. Name test. And we set active status to false again. Set active status to false again. Cool. Nice. Sweet. Awesome. So now we have setting active status happening appropriately. I create a menu use today's date. So if I press 5, set item active status. Should I clear? If I don't clear when I do the name, I don't clear. The size I don't clear. The cost I don't clear. The date created I don't clear. And the active status I don't clear as well. Interesting. All right, you guys, that was cool. So we successfully added in the functions for overriding the active status from true to false via this function here. Um, it now all of the actual overriding of these five attributes, the item name, size, cost of good, date created, and active status, are working appropriately for all of these associated items. And then it's effectively saving those items after we press 6 here. Boom, that just got updated with those values. So super cool. That's working appropriately. So now also we added in the view for all items. So now we have the view for all items happening appropriately as well. So if we wanted to manipulate this for like a pandas or something, we could do that here as well. So we have add, we have the find edit item done, and we have one part of the view. So now we need to actually start working on the transaction part of this project, which is the real meat and potatoes of it. So we are now ready to actually start transitioning our items from just a inventory status of item to a for sale status by giving it a date create or a date listed and a listing price, and then having a transaction for a sold item where we can transaction a for sale item into a sold item. So super cool. I really appreciate you guys joining me today, and you know, sticking with me in the learning. And just a quick overview at the beginning, we took a stab at four of the Python, the data structures and algorithms in Python practice problems. We did four of them at the end of chapter 5 on dynamic arrays and array-based sequences. And then we started on to chapter 6. So tomorrow we'll take a stab at finishing up the last couple of reinforcement problems in chapter 5 and continuing on with chapter 6. And then we will work on adding features for converting these items into actual sales and managing, the actual reports of sales and things like that. So we're really making progress here little by little, and I'm super excited to continue on and keep going. So thank you guys so much for joining me today. If you guys are following the stream and aren't subscribed, consider following along so I can, chat with you guys every day. Also join the Discord down below so I can chat with you guys offline, and you can get access to all my study resources and, follow the same pathway I am in my learning and education for self-taught computer science. Like the stream, if you enjoyed this stream I did tonight, we streamed for almost 4 hours. So a very long, detailed and very productive stream today. Really putting in the time and the hours needed to master this material. I'm really dedicated to learning it, and I hope that can rub off on you guys and help inspire others to feel the same way. Again, thanks so much for watching, you guys. This has been Sunday, December 22nd. I will see you guys later. I'm going to just wait one more minute until we hit the 4-hour mark exactly, and I'll end it off there. Any last chats here before we end the stream? Let me know. Any speak now or forever hold your peace. I really appreciate you guys joining me today. Honestly, it takes a lot of effort on your guys' part as well to pay attention, watch these streams, figure out what's going on. So give your own selves a round of applause and a pat on the back for staying dedicated and learning this as well alongside me. I think tomorrow I might start adding in an additional flag, apart from the active flag, but like a for sale and a sold flag, so we can have just a direct true or false Boolean to determine and factor out if the items are sold. They will be technically sold and for sale if they have a date listed and a date sold, right? But I think maybe just a true Boolean, true or false, would be more readable and better to categorize those. So we'll implement that tomorrow. I'll see you guys then. And we got 10 more seconds. 8, 4, 5. We are at ending the stream today on 568 subscribers. Wow, so exciting. Almost to 570. This is just truly unbelievable. I made a short last night regarding my recursion problems and my reaction. I just made a quick short, and so go ahead and check that out, and I'll see you guys later.